You all would agree with me when I say that we are more interested in studying the non-degenerate conics rather than the degenerate ones. Right? So from now on, whenever I say the word conic, I would by default be referring to the non-degenerate conics rather than the degenerate ones, even if I don't say it. Okay? Now tell me, there are 4 non-degenerate conics: circle, parabola, ellipse, and hyperbola. Right? You and I together will be diving deep into the world of parabolas and understanding it with utmost detail, utmost clarity, and utmost precision. Let's start. To begin with, what is a parabola? A parabola is a conic with eccentricity 1, isn't it? To put it simply, I mean that a parabola is the path traced by a moving point such that at each position of its movement, the ratio of its distance from a fixed point, focus, and the distance from a fixed line, directrix, is equal to 1. Again, to make you understand it in a simpler fashion, let's say P is the moving point, S is my fixed point, that is focus, and this line L that you can see over here is my directrix. So, parabola is nothing but the curve traced by the point P under the condition that its distance from the focus, that is PS, upon its perpendicular distance from the directrix, that is PM, is equal to 1. That's it. This in the next step gives you PS is equal to PM, which if you try to read, it says distance of P from the focus is equal to the perpendicular distance of P from the directrix. This, boys and girls, is not a trivial thing that you have obtained. In fact, this is the massive and most important fact about a parabola. What is it? Well, it says that if P is any random point sitting on the parabola, then its distance from the focus will be exactly same as its perpendicular distance from the directrix. Do you get it? Yes? Hence, this particular property I want you to register in your minds very, very thoroughly because it is extremely useful and highly applicable. You will see that for yourself. The very first case is when the focus is lying on the positive x-axis placed at a distance of a units to the right of origin. That means the coordinates of the focus are a, 0. And the directrix is the line parallel to y-axis lying at a distance of a units towards its left. That means its equation is x equals minus a. Now, with this focus and this directrix, I want to find the equation of the parabola. So what I'm going to do, exact same drill. Let's say P is the moving point which is moving under the condition that its distance from the focus is exactly equal to its perpendicular distance from this directrix. Okay, then what I want to find the equation of the curve traced by this point P. Or in other words, I want to find the locus of point P, isn't it? Now, if I want to find the locus of point P, the first thing I'm going to do is take the coordinates of P as h, k and now use the condition that PS is equal to PM to the maximum level possible. Okay, so now PS, use a distance formula to find out PS. What will it be? It will simply be under root of h minus a whole square plus k minus 0 whole square. Okay, now next is PM. Now PM, if you carefully observe, is Mn plus Np. And if I talk about Np, it is nothing but the x coordinate of point P. And if I talk about Mn, you already know that the line, that is the directrix, is a units away from the y-axis. So Mn is going to have length a units. That means if I talk about complete PM, it is nothing but Pn plus Nm, that is h plus a. Now in the next step, I'm going to obviously square both sides. When I do that, what do I get? Let's see. This, when you take to the right hand side, you end up getting k square equals h plus a whole square minus h minus a whole square, which kind of resembles x square minus y square, that is x plus y into x minus y. So further, plus a minus a cancels out, this gives you 2h, and from here plus h minus h cancels out, you're left with 2a. So eventually what you are left with is k square equals 4ah. Now k square equals 4ah is nothing but the equation involving h, k and constants, which is free from any unnecessary parameter or variable. Right? So we are almost through. You know the last step. I'm going to replace h with x and k with y. What do I get in the next step is y square equals 4ax. This tiny, pretty, cute looking equation is the equation of my standard parabola, which has its focus at a comma 0, where obviously a is positive, and the directrix at x equals minus a. So did you see the magic of restriction? The moment I restricted the positions of the focus and the directrix, my not so pretty looking equation of the parabola has actually been converted to a very nice and very simple to remember looking equation of the parabola y square equals 4ax. Well, now I'm sure you would be wondering, how does this particular parabola look like? Isn't it? We know that y square equals 4ax, where a is positive, represents the equation of a parabola, which is a standard parabola, having its focus at a comma 0 and directrix at x equals minus a. But again, same question. How does this parabola look like? So what I'm going to do is I am going to collect all the infinitely many points which are equidistant from this focus and from this directrix. Okay, let's start doing that. So P1 is a point equidistant from the focus and the directrix. Next, P2 is a similar point. P3, P4, P5, P6, P7, and so on. When you collect all such points which are equidistant from this focus and this directrix, what you end up getting is this rightward opening parabola having its vertex at origin to be the standard parabola whose equation was y square equals 4ax. Look at it peacefully. It is having its mouth open towards the focus, whereas the directrix is lying towards its back. Alright, this rightward opening parabola having its vertex at origin is what is represented by the standard equation y square equals 4ax. Now, let me give you a mathematical justification for getting this to be the parabola corresponding to this equation. See, first of all, there are many observations. The very first one is that x equals 0 if you plug in and y equals 0 if you plug in. This equation gets satisfied, right? That means origin is going to lie on this parabola for sure, or this parabola is going to pass through the origin, which is being justified, as you can see. Okay, that's the first observation. Second, observe that y square is non-negative for every y real. On the right hand side, if you see, a is positive, 4 is positive, so 4a is positive. For 4ax to be positive, for 4ax to be non-negative, x has to be non-negative. Do you agree? You have y square equals 4ax, y square is always non-negative, and a is positive. So for 4ax to be non-negative, x has to be non-negative. That means the graph of this particular equation is only going to be drawn corresponding to the non-negative x-axis, which is again being justified by the figure that you can see in this diagram. the graph is only drawn in the first and the fourth quadrant. There is no portion of the graph lying in the second and the third quadrant. Do you agree? Yes? All right. Next observation. Well, if you have y square equals 4ax, this in the next step gives me y equals plus minus under root 4ax. Now, you know x is only allowed to be non-negative. Okay, x is only allowed to be non-negative. So, if you plug in x equals 0 in here, you will get y equals 0, giving you 0, 0 to be the point lying on this curve. True. But if you plug in any strictly positive value of x, let's say x1, okay, any strictly positive value of x, then corresponding to this value of x, you will get two symmetrically opposite values of y. One will be plus under root 4ax1 and another one will be minus under root 4ax1. Do you agree? That means these two outputs are same in magnitude but opposite in sign. Which means how much ever is this length, exact same is this length. Which means at x1, whatever is the spread of the parabola above it, same is the spread of the parabola below it. In fact, this is true for every positive value of x, because corresponding to every positive value of x, you get two symmetrically opposite values of y. And that justifies the shape of this curve. Do you agree? That justifies the shape of this particular curve. In fact, I can also say that this particular curve is symmetric with respect to the x-axis. Because the portion of the graph above the x-axis, if you flip it about the x-axis, you will get the portion below. Because the below part is mirror image of the above part and the above part is mirror image of the below part. Wherein x-axis obviously I am treating as the mirror. Understood? Right? And last observation. As you keep on increasing the values of x along the positive x-axis, the corresponding values of y also keep on increasing in magnitude. And that is why the mouth of the parabola is gradually keeping on increasing. Do you agree? So these four observations justify this particular parabola, which is a rightward opening parabola having its vertex at origin, to be the parabola represented by this standard equation y square equals 4ax. Before I move further, there's just one little observation that I would like to discuss with you, which is really, really important when it comes to question solving. What is it? You know that in a parabola, every point sitting on that parabola is equidistant from the focus and the directrix. Now, in here, you know as a matter of fact that the origin is sitting on this parabola. So, even it is equidistant from the focus and from the directrix. In fact, you know the exact distance. It is a units away from the focus and a units away from the directrix. That means you can clearly write this down in your notebooks as well, that this small a, which is a positive real number in this equation, actually represents the distance between the vertex and the focus, or the distance between the vertex and the directrix. I can also now I'm in a position to say that vertex is the midpoint of the perpendicular line segment joining the focus and the directrix. Basically, if you drop a perpendicular from this focus onto this directrix, the midpoint of that perpendicular is what is the vertex. Do you understand? Right? Now, there are certain terminologies associated with this particular parabola. Let us acquaint ourselves with all of them. The first one is the axis of symmetry. Well, it is nothing but a line about which my parabola is symmetric. For this parabola, you know it is the x-axis, right? Formally, we define the axis of symmetry to be the line passing through the focus and perpendicular to the directrix. Got it? Next is the vertex, which you know for this parabola is at the origin. But as you can clearly observe that my parabola and my axis of symmetry are intersecting each other at a single point. This point of intersection is what is being named as the vertex, formally. Alright, next up is double ordinate. But before I discuss double ordinate, I want to discuss the meaning of chord of a parabola. Now tell me, what is chord of a parabola? It's very simple, very basic, very straightforward. You will say take any two distinct points on the parabola. Now you join them. What you get is a chord. Right? Now, if this chord happens to be perpendicular to the axis of symmetry, it is called a double ordinate. Do you agree? Yes? Understood? Any chord which is perpendicular to the axis of symmetry is called a double ordinate. So this chord is a double ordinate. Even this one, even this one, even this one, even this one. That means a parabola has infinitely many double ordinates. Got it? Next is a focal chord. As the name suggests, it's just a chord which is passing through the focus. So if you look at this one, this is a chord which is obviously a focal chord, isn't it? In fact, I have infinitely many focal chords in a parabola. Right? I have infinitely many double ordinates. I have infinitely many focal chords. Now I am interested in adjoining these two. I want a chord which is a double ordinate as well as it's a focal chord. That means I am interested in getting a chord which is perpendicular to the axis of symmetry and is also passing through the focus. This is one and only one single unique chord which is called the lattice rectum. Okay, so a parabola has a unique lattice rectum which is a chord perpendicular to the axis and passing through the focus. So in here, PQ is my lattice rectum. We are interested in two aspects of lattice rectum. The first is finding the coordinates of the endpoints of the lattice rectum. Second is finding the length of the lattice rectum. Alright, now you know that in here the focus is having coordinates as a, 0. And this PQ chord is perpendicular to the x-axis, which obviously makes me say that the x coordinate of P is going to be A and also the x coordinate of Q is going to be A. Right? Now let's say y0 is the y coordinate of point P. P is lying on this parabola whose equation I know is y square equals 4ax. So the coordinates of P are going to satisfy this equation. That means I am going to get y0 square equals 4ax, where the x coordinate of P is A. So what do I get? y0 square equals 4a square, which means y0 is plus minus 2a. Which obviously makes me say that P is going to be a, 2a and Q is going to be a, minus 2a. Right? Yes, that means the endpoints of the lattice rectum are known to me a, 2a and a, minus 2a. At the focus, the parabola is 2a units above it and 2a units below it. So the spread of the parabola at the focus actually means the length of the lattice rectum. What is that? This is 2a. This is 2a. So all in all gives you 2a plus 2a, that is 4a. That means the length of the lattice rectum actually is 4a. Length of LR. Again, I would repeat the endpoints of the lattice rectum, a, 2a and a, minus 2a, which signify that at the focus, the parabola is 2a units above it and 2a units below it. That means, what? That how much the parabola is spread at the focus is going to give me the length of the lattice rectum, which comes out to be 4a. And at this point of time, I really want to share this with you, that in the equation y square equals 4ax, the coefficient of this linear variable x, that is 4a, is nothing but the length of LR. So if somebody gives you the equation of the parabola and asks you to find the length of the lattice rectum, just catch hold of this 4a quantity and declare that to be your answer. And lastly, I want to discuss about the focal distance, which is nothing but the distance of any random point sitting on the parabola from the focus. Okay, so in particular, I know that origin is definitely sitting on the parabola. So what is its focal distance? That means the distance of origin from the focus. Well, you already know it is a units, right? But if apart from origin, I consider any random point sitting on the parabola, okay, apart from origin, let's say A is some point sitting on the parabola having coordinates x, y, then I am interested in finding its focal distance. That means I am interested in finding its distance from the focus, that is length of the AS segment. Now, one way is to use your distance formula to get the length of the AS segment, which is going to be a little tedious process. Instead, what I'm going to do is I'm going to use the fact that any point on the parabola is equidistant from the focus and the directrix. So I'm going to drop a perpendicular from A onto the directrix, and rather than finding AS, I'm going to find AT because I know AS is equal to AT. Finding AT is any day easier. You are going to realize that just now. See, if I name this point as N, then the length of the AN segment is nothing but the x coordinate of point A. Do you agree? See, in here, for this parabola, x is only allowed to be non-negative. We have dealt with origin. Right now, the x coordinate of point A is strictly positive. So the length of the AN segment is x. Cool? What about Tn? My directrix is A units away from the y-axis. That obviously means the length of the Tn segment is going to be A. I know AT is AN plus NT. That means x plus A. So what are you getting? That the focal distance of point A is coming out to be x plus A. That is the x coordinate of point A plus A. Isn't it? So we have understood that origin is A units away from the focus. And any other point if I take on the parabola, that is x plus A units away from the focus. Right. In fact, for a particular case, if you take A to be the origin itself, then x plus A will just come out to be 0 plus A, which is A, which justifies the fact that origin is A units away from the focus.